Hi everyone, and welcome to our video for Venn diagrams and Karnaugh maps. For this one, we're going to go through two different diagrams, so two different visual ways of representing and calculating probabilities. And we're also going to go through some of those formulas on your formula sheet here. The addition rule, conditional probability, and independent events. So you can see there that the notation, okay, that we saw briefly in the first video, but just remember that this means or and this means and. Okay, so the probability of A and B happening, we're looking at where they both occur, and A or B is when either of them occur. Now, we need to know the difference between independent and not independent events. So independent events don't cross over at all. Okay, so you can see they're aces and kings. They've got nothing in common. They don't intersect at all. Whereas hearts and kings, the king of hearts there intersects. So when we talk about independent, we're talking about two sets of data that have nothing in common. Okay, and we need to know that because you can see here, independent events have a different rule than non-independent. So if they cross over, we've got to take that into account. Okay, so the addition law, and this will become very clear when you actually use the diagrams, states that the probability of A or B is both of them. Take away this bit in the middle that we've actually counted twice. Okay, so that A and B in there, we counted it once in B and we counted it again in A, so we've actually doubled up, so we need to take it away at the end. Okay, so whenever we do something, let's say for this kings and aces, kings and hearts, we actually have 4 kings, okay, and we have 13 hearts, but there's only 3 in here and 12 in here. You've actually got to take away the one that's in the middle there, okay? All right, so let's try an example with Venn diagrams. So I've got my, I'll get a blank one. I've got my Venn diagram template here, and we want all the numbers up to 10. So I'm just going to write all the numbers up to 10. So 1, 2, 3, 4, 5. Didn't leave myself enough room there. So that's all of our data. Okay, so we've got 10 pieces of data that we have to sort out. Now I've got prime numbers and we've got numbers less than 6. So let's make this one prime numbers. And let's make this numbers less than 6. Okay, and this is both. So prime numbers, we've got 2, 3, 5, 7. So 2, 3, 5, and 7. And numbers less than 6, we've got 1, 2, 3, 4, 5, nope, 25. Okay, 5's in both of that, so we've actually got to take it out of there and put it in the middle. And 2's in both of those as well, so we've got to take that out and put it in the middle. Okay. Now, there are some numbers that aren't either of those. So we've used 1, 2, 3, 4, 5, and 7, but we've still got 6, 8, 9, and 10. Bam's having a sook in the background. So all of these have to be included, okay? When you've finished, you need 10 pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have done something wrong. Oh, 3 to go in the middle as well. Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's better. So your entire Venn diagram has to add up to all the data. And if you've got percentages or decimals, it needs that to add up to 1 or 100%. Okay, so just keep that in mind. So that was a pretty simple one. And we can see there that the both are in the middle, prime numbers less than 6. Let's try it with a bit more notation. So the probability of x is 0.25, probability of y is 0.32, and the probability of x or y is 0.43. So I'm going to set my Venn diagram up by first of all labeling it. So let's make this x, this can be y, and this can be x and y. Right? So out here, this is not x and not y. Right? And you'll kind of see all these notations coming in here. So probability of x is 0.25, probability of y is 0.32. The problem is if we go 0.25 plus 0.32, we get 0.57. But it says that x and y together, so probability of x or y, is actually 0.43. Okay, that means there's going to be an overlap. So what we're going to do is we're going to go 0.57 take 0.43, and we're going to find out what this overlap is. And it's 0.14. So there's an overlap of 0.14. Okay, so all of x, the whole circle of x, has to add up to 0.25. We've already used 0.14, which leaves us with 0.11 with just x and not y. And y has to add up to 0.32. We've already used 0.14. I realise I should be able to do this in my head, but I can't. 0.18. Okay. Now we need all of this, the entire Venn diagram in that box, to add up to 1. Okay, so we've got 0.43 that is included with x or y, but we've got to figure out what is not x and not y. So we're just going to take 0.43 away from 1, and we're left with 0.57. Okay, and in a test or an assignment, you will count these up and make sure that that adds up to 1. Sorry, had to hurt my dog. Okay, so let's bring all this together and try and do an example from start to finish. So we've surveyed 100 Year 7 students on their ice cream preference. Some like chocolate, some like vanilla, some don't like either. Okay, and the first question there asks us to represent this information in a Venn diagram. So I'm going to use C for chocolate and V for vanilla, which means that the crossover will be C and V, and the neither will be not chocolate and not vanilla. The first thing that we need to do is put in the information that we have. So we know that 45 like vanilla, but we don't know how many of those also like chocolate. But we know that 15 don't like either of them. That's easy. Okay, so in our two circles there, we have to put 100 take 15. No. Okay, we've got to get 85 into those two circles. All right, now 45 like vanilla and 55 like chocolate. So 45 plus 55 gives us 100, and we can only put 85 in there. So we're going to take away 85, which leaves us with 15 as a crossover. Okay, that's just a coincidence that those numbers are the same. They're not always the same. All right, so 15 people like both and 45 like vanilla. That means that 30 students like vanilla but not chocolate. Okay, 30 plus 15 gives us 45 liking vanilla. 55 students like chocolate, which means that 40 like chocolate but not vanilla. That's 40 plus 15. That gives us 55 students who like both, just like chocolate. So we're going to add them up. 40 plus 30 gives us 70, plus 15 gives us 100. So that we've got all our data in there and it's all covered. Okay, so once you've got your diagram set up, then you're going to try and answer the questions. So determine the probability that a randomly selected student preferred chocolate. Okay, now, so do they like chocolate? Well, we've got 55 students who like chocolate out of 100. Okay, that's our probability. The second one there, determine the probability that a randomly selected student only likes vanilla, is a bit different. They only like vanilla. So they don't like vanilla and chocolate. They only like vanilla. So that one would be 30 out of 100 students. Okay. So let's try and do this again using those formulas, because you're not always required to draw a Venn diagram, but it's a really good way to get your thinking straight. So here, the probability of A or B. So our probability of A or B would be probability of A, which was 45 in the original question, plus the probability of B, which is 55 in the original question, and probability of A and B in the middle there is 15. So 45 plus 55 gives us 100, take 15, 85. So the probability of A or B is 85, right? And if you've got part of that information, so if you've got A or B and A and B, you can find A and B, right? You can find parts of those formulas. Now that addition rule works for independent events. It also works for non-independent events. So if you don't have a crossover, that just becomes 0, take 0 is nothing. Okay, so this works for either. However, this one here only works if they're independent, if they don't cross over at all. So that's Venn diagrams. Let's have a look at Karnaugh maps. Okay, so these are the same thing. They're the same. You're finding the same thing with them. They're just a different way of doing it and displaying it. So on the left here, you've got a grid missing a few bits, and here's just a 4x4 grid. Either one's fine. It doesn't matter which one you use. I find the second one easier to draw, but you can use either. So we're going to try and fill in this information using the same questions that we just did with the Venn diagrams. And what we're going to do, we're going to make each of the headers, so this could be the probability of X, and this could be the probability of not being X. Okay, same down the side, probability of Y occurring, probability of Y not occurring, and the total has to add up, in this case, to 1. Okay, or 100% in the data, but this case we've got decimals, so we're going to add up to 1. Now we can fill in a bit of this information. The probability of X occurring is 0.25. So this is the X occurring column here. So they could, say if we're talking about the ice cream, they could like chocolate or not like chocolate, it doesn't matter, they still like vanilla. So the total goes down the bottom here. All right, so just X, no reference to Y, so it doesn't cross over with the Y's, just X is 0.25. Probability of Y occurring is 0.32. So again, no reference to X. It doesn't cross over with X, so it's just going to go there. What else have we got? We've got the probability of X or Y is 0.43. And I've started you off on a bit of a hard one here, sorry. So X or Y is actually telling us something else. So there's no spot for X or Y on there, but there is a spot for not X and not Y. Okay, so if X or Y is 0.43, then not X and not Y is going to be 0.57. Okay, so X or Y are filled up with 0.43, and that's what we've got left. Now, the Karnaugh tables, it's pretty much where the totals column are, so they have to add up. So 0.32 and this have to add up to 1, so that would be 0.68. Has to add up to 1 across this way, so 0.25 and 0.75 will get us to 1, and same going down here. So 75 and 57. What do we got? 0.18. Okay, so all the columns and all the rows add up. So 0.32 and 18 gives us 0.14. Whoops. And 0.14 gives us 0.25. Okay, some people that suits them a lot better than the Venn diagrams. I personally really like the Karnaugh maps once you get your head around them. Some people preferred Venn diagrams. And again, that helps us use these formulas really nicely so we can find out all this information using these two diagrams. So let's try another example. Again, with the ice cream one, I've changed the questions a little bit, but the situation's the same. So 100 students are surveyed. Therefore, the total that we're looking at is 100. Right? We have likes chocolate, doesn't like chocolate, likes vanilla, doesn't like vanilla. And 55 students like chocolate. So no reference to vanilla. We don't know if they like vanilla or don't like vanilla. We just know that they like chocolate. So the total for the chocolate column is 55. And the total for the vanilla row is 45. 15 students don't like either. So not chocolate, not vanilla is 15. Okay, now we can fill all that in, and that's the start of your exercise. You'll just be filling them in. You'll just be calculating them before you have to create them. So 45 and 55 will give us 100. 55 and 45 will give us 100. 30 and 15 will give us 45. Okay, so that's filled in. So let's go through these questions. Determine the probability that a randomly selected student didn't like either. So not chocolate, not vanilla, we've got 15 out of 100. Okay, determine the probability that a random selected student liked only both. I think that's meant to be liked both. So again, there's 15 out of 100 that like vanilla and chocolate. What are the chances of a student liking both flavours given that they like chocolate? Now, this is a conditional probability. They're telling us that they already like chocolate. What is the probability of picking a student out of the people that like chocolate that likes both? Okay, and that's this here. Okay, so the probability of A happening given that B's already happened. So the probability of a student liking both given that they like chocolate. And you can see up there the formula is the probability of A and B occurring, so that's this here, 15, divided by the probability of B occurring, which is 55. Okay, so out of the 55 students that like chocolate, 15 like both flavours. Okay, so two visual ways of representing those formulas. We're now going to try one just with a formula. Oops, let me just copy that. Sorry, I've stolen these slides from last year, and those formulas are from last year. So we're going off this one here. So if the probability of A is 0.4, probability of B is 0.5, probability of A and B is 0.2, what is the probability of A or B? Now, we can see there that there's an A and B of 0.2, so they overlap, they are not independent. So we're not using this, we're going for one of these two, and we're going to go for the addition rule. So we want to find the probability of A or B. We've got the probability of A, that's 0.4, probability of B is 0.5, and the probability of A and B is 0.2. Okay, so 0.4 plus 0.5 is 0.9, minus 2 is 0.7. So the probability of A or B occurring is 0.7. Okay, so pretty simple once you know what you're looking for, and if you do those graphs and maps first, that'll really help you get your head around it. Enjoy. Sorry for the long theory video.